Well, welcome to this online revision session for AQA FP2, in which we'll be looking at the June 2011 question 5 on arc lengths and surface areas. You can see in this particular question we're looking at the arc of the curve y squared equals x squared plus 8 between the points where x equals 6 and x equals 0. And we're rotating it through 2 pi radians, and we're then being expected to show in the first part of this question that this is the form of the surface area, and then we're given a substitution in part B to actually calculate that particular integral. Now in the formula booklet you will find there are suitable formulas for working out the surface area and the arc lengths. In this particular case we're involved in a Cartesian equation involving x and y, so the surface area that we require is given by 2 pi integral of y square root of 1 plus dy by dx squared dx. So trying to remember that, we know surface area is equal to 2 pi integral of y square root of 1 plus dy by dx squared dx. So in order to come up with the integral for this, we'll need to firstly find dy by dx. Well, we know that y squared equals x squared plus 8, so if we differentiate this implicitly, the y squared has to be differentiated with respect to y, which is 2y, and then multiplied by dy by dx. And then on the right hand side, in differential of x squared is 2x, differential of 8 of course is just 0. So if we rearrange this, we get the fact that dy by dx will be equal to y over x, x over y. So now if we substitute these into here, we're going to get 2 pi integral of y. Our limits, of course, are going from 0 to 6. And then we've got the square root of 1 plus x squared over y squared, because remember dy by dx is x over y, and that's being squared. Well, it doesn't quite look like the one that we require yet. So what can we do? Well, we can I think what we need to do here is to combine these 2 parts underneath the square root together, and then we may well be able to take a suitable factor out to make that y in front of the square root disappear. So we're going to get y square root, so this is going to become y squared plus x squared over y squared. And now we can take the y squared out of the square root and it will cancel this y on the outside. Now we've got to get this all as a function of x inside this integral. So we've got the integral from 0 to 6 square root. Well, what do we know about y squared? Well, that's the same as x squared plus 8. So plus the other x squared gives us 2x squared plus 8. And so we can take the factor of 2 out from there, which will give us our root 2 out the front. So we get 2 root 2 pi. We're taking that factor out. And inside the square root we're left with x squared plus 4 dx. It's very easy to go off in the wrong direction with that one and end up with something which is very messy, so you have to think about it quite carefully. Well, how are the marks allocated for each part of that? Well, for the statement relating dy by dx after the implicit differentiation, you'll get a mark for that. Then you will get 1 mark for then substituting that in to give you an appropriate integral, together with an accuracy mark for getting that correct, and then simplifying it by eliminating the y's will be a method mark, and then finally simplifying it down to what you require and an accuracy mark there. So that will be your allocation of the 5 marks. Now part B, we're now looking to use this substitution to find the integral to this original statement. So if you remember to do a substitution, you will need to firstly find out what dx by d theta is. So we should know. Notice here we're overlapping this topic with hyperbolic functions. So dx by d theta will become 2 cosh theta. So when we substitute that in, I'm going to need lots of room for this, so substituting it in, we're going to get 2 root 2 pi. Remembering the integral is from x equals 0 to x equals 6, and we're substituting in for theta into the expression, so we won't worry too much about the limits at the moment, and we'll come back and worry about them at the end. So we then get the square root of cosh squared theta when we substitute in x, yeah, but it's, sorry, shine, looking at the wrong thing there, it's shine we're substituting, and it's also got a 2 in front, which when we square it gives us 4, and then we got plus 4 at the end of there, d theta, and to get d theta, at d theta is also multiplied by 2 cosh theta, so hang on a moment, let's put the 2 cosh theta in. D theta. Right. Okay. Now if we tidied that up a bit, we're going to get 2 root 2 pi integral. A factor of 2 comes out from this root bracket here, and then you're left with shine squared plus 1, which you should know is cosh squared, because if you remember, cos squared plus sine squared equals 1, but when you change it to cosh and shine, anything that's a sine squared changes sign, so we get cosh squared minus shine squared equals 1, so cosh squared is equal to shine squared plus 1, and of course we're square rooting that, so this just becomes cosh theta, and then we got another 2 cosh theta here. So all told, that gives you of course a cosh squared in this expression. Now to integrate cosh squared, just like cos squared or sine squared, we need to use a double angle formula, and for that we're going to need to know the fact as to what cos 2 theta equals, or cosh as the case may be, and cosh 2 theta will be equal to twice cosh squared theta minus 1, and you need to be able to find that out for yourself. Okay, if you know the double angles for formula for coses and sines, then that would be particularly helpful because you can then just substitute. And so if we rearrange this, we're going to get the fact that cosh squared is equal to cosh 2 theta plus 1 over 2, and so this is going to become twice root 2 pi integral, one of these 2's is still going to be there, but the 2 cosh squared is going to be replaced by cosh 2 theta plus 1. D theta. Okay. Now we can do that integration. Put square brackets there. Well, differential of cosh 2 theta is going to be sine 2 theta over 2. And the differential of the 1 is going to be theta. And of course there was a 2 here, which I could just put on the outside of this, and this would then become a 4 here. Okay, now the limits that we got, if you remember, were x equals 0 and x equals 6. So we can either change the limits, or we can change the thetas back into their respective expressions in terms of x. And I think under this one I'd probably go for that. So what do we get if we do that? Well, what have we got? We've got 4 root 2 pi integral. Now this is sine 2 theta, and the substitution was 2 sine theta, so we've got to rewrite sine 2 theta in terms of sine and cosh, because we know through the double angle formulas that sine 2 theta is twice sine theta cosh theta, so the 2 will cancel, so we're just left with sine theta cosh theta plus theta. But what is theta? Well, we know theta is going to be found through rearranging x equals 2 sine theta in a moment, so we'll do all that in the next line. Okay, so again that's between x equals 0 and x equals 6. Now notice I'm making it clear that these are values of x. So we've now got to do the appropriate substitution. So this becomes 4 root 2 pi. Well, we know that sine theta is going to be x over 2 when we rearrange x equals 2 sine theta. As for cosh, well, the cosh function, we're going to have to rewrite that in terms of sine, and we know that cosh squared minus sine squared equals 1. So cosh squared equals 1 plus sine squared. So it must therefore be the square root of that. Well, 1 plus sine squared will become 1 plus. And what did we say sine was? Well, we just said it was x over 2. So this becomes x over 2 squared. And then we've got to replace the theta. Well, if x equals 2 sine theta, x over 2 equals sine theta. So theta is sine to the minus 1. The inverse function of x over 2. You certainly make your work for your 8 marks in this question. Okay, well, we're getting close to the answer now. So now we can substitute in the various values. So we got 4 root 2 pi. Putting in 6, well 6 over 2 is 3. And putting 6 into this, 6 over 2 is 3. 3 squared is 9 plus the 1 makes 10. So that's 3 root 10. Plus, put 6 into this and we get sine to the minus 1 of 3. And we can leave it in that form. Look at the answer. It's there. Put 0 into the first part and we get minus 0. Put 0 into the second part and we got sine to the minus 1 of 0, which you should know from the shape of the graph, which looks a bit like an x cube sort of a graph. It goes through 0. Okay, so now it's just a case of tidying it up into the form that they want, and you can see we've got a pi as a factor. We take the 4 root 2 and multiply it by 3 root 10. Well, 3 times 4 is 12. Root 10 can be written as root 2 root 5, which will give you another root 2 times the root 2 here, which will give you another 2. Double in the 12, that makes 24 root 5 as required. And then the sine to the minus 1 of 3 is multiplied by the 4 root 2 that you brought into that first part inside the bracket. Whew, got there. Right, allocation of the marks in this particular part of the question. Well, again, stating that dx by d theta is equal to 2 cosh theta, that will give you a mark for that. Then from there, it's a method mark for an appropriate attempt to substitute in there. Then in here, let's see, you'll get a mark, I think, for coming up with the cosh theta here. And similarly, you'll get a mark for getting the cosh 2 theta plus 1 by using the double angle formula. Doing the correct integration and getting this statement would give you 1 mark. Following through, and then again using your double angle formulas to get to this point would give you a mark, and then reducing it into something which is of the form in terms of x, or if you decided to change the limits, having the correct limits being changed, and then finally an accuracy mark at the end for managing to substitute the values in and reducing it to the form of the final answer. Well, hopefully you found that solution useful. For further support for your studies, please go to the Further Maths Support Programme website